Good morning, students. This is SHAFI from Don Bosco PU College, Chitradurga. In our previous class, we learned about the definition of a function, also the domain and codomain and range of a function. In this class, we are going to discuss about the types of functions. There are so many types of functions, particularly some 4 to 5 functions we have. Let us discuss one by one, and also these types of functions are important for 5 marks compulsory. You will get one 5 marks questions in these types of functions. The very first one is a identity function. What is meant by a identity function? A function f from R to R. A function f from R to R. R is nothing but a real number. It is also a real number. A function f from R to R is defined by f of x equals to x for all x belongs to R. Is called a identity function. Is called a identity function. It is the definition of a identity function. A function f from R to R is defined by f of x equals to x, where x is a real number, is called a identity function. You just observe here we have a function f from R to R. R is a domain, R is a codomain. What about range? We will discuss later. It is the definition of a function. Let us draw a graph of a identity function. Let here, by the definition of identity function, we have f of x equals to x. Let f of x equals to x, where for all x belongs to a real number, where x is a real number. Let us take a graph. Let us take the values. Let us take the values in a table. It is x, it is x, it is f of x, that is f of x equals to x. Five, 4, 3, 2, 1, 0. So these are the negative values: -1, -2, -3, -4, -5, -6, -7, -8, and so on, like that. These are the positive values: 1, 2, 3, 4, and 5. Let us apply a identity function. Here we have a -5. If x equals to 5, then f of x is what? -5 only. If x equals to 5, f of x is also a -5. If x equals to -4, then f of x equals to -4. In place of x, you just put -4. Output is also, we will get to -4. If f of x equals to -3, if f of x is -3, then x is also a -3. It is a -2, -1, 0, 1, 2, 3, 4, 5. It is a table which belongs to a identity function. Let us draw the graph for this function. Here we have the graph for identity function. Let us draw the graph for this function. It is x-axis, it is y, it is origin, it is negative x, and it is negative y-axis. Let us take the values on positive x-axis 1, 2, 3, 4, 5, 6 and so on. Let us take the values on negative x-axis -1, -2, -3, -4, -5, -6 and so on. Similarly, let us take the values on y-axis 1, positive y-axis 1, 2, 3, 4 and 5, 6, 7, 8, 9, 10 like that. Let us take the values on the negative y-axis -1, -2, -3, -4, -5, -6 and so on. You just see the table for this function. You just see the table for this function. If x equals to 0, then y, f of x equals to x, is also denoted by y. If you want to take, you can take x, y. Let y equals to f of x also equals to x, or x, y you can take. If x equals to 0, then f of x is 0. If x equals to 1, f of x is 1. If x equals to 2, f of x is 2. If x equals to 3, f of x is 3. Let us take these values in a graph. You just observe the table. If x equals to 0, f of x is also 0. F of x is nothing but y. If x equals to 1, y is also 1. Okay. If x equals to 2, y is also 2. If x equals to 3, y is also plus 3. If x equals to 4, y is also 4. That means y is nothing but f of x equals to y. If x equals to 5, y is also 5. Similarly, if x equals to 6, y is also 6. If x equals to 7, y is also 7. If x equals to 100, y is also 100. Now, if x equals to -1, y is also -1. If x equals to -2, y is also -2. If x equals to -3, y is also -3. If x equals to -4, y is also -4. If x equals to -5, y is also -5. You just join these points with the help of a scale. Finally, you will get the graph for identity function. Join these points. Finally, we will get a graph for this function. It is the graph for identity function. Hence, this graph is important for your point of examination. It carries 5 marks. You just note down this graph in your graph notebook without making any kind of mistakes. Once again, you just go back. It is the definition of an identity function. It is the definition of an identity function that a function f from R to R is defined by f of x equals to x, where x is a real number, is called identity function. Let us take, by using the identity function, let f of x equals to x, where x is a real number. If x equals to 0, f of x is also 0. If x equals to 1, f of x is also 1. If x equals to 2, f of x is also 2. Like that, we will draw a table. Now, for this identity function, let us find out domain, codomain and range for this function. What about the domain? What about domain? What about codomain? What about range? What about range? You just see in the definition itself we have domain, codomain. You just observe in the definition itself we have domain and codomain. A function f from R to R is nothing but a real number. This also represents a real number. R is a domain, R is also a codomain. Therefore, domain and codomain both will be real numbers. Both will be real numbers. Real numbers are represented by capital R. Codomain is also real numbers. Codomain is also real numbers. Now, what about range? What about range? The output values of x, the output values of f of x is called a range. You just observe f of x equals to x we have. You just identify these numbers. You just identify these numbers. These numbers are the range for this identity function. 0, 1, 2, 3, 4, 5, 6 and so on. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9 and so on. All these are the range for this identity function. You just name it for these numbers 0, 1, 2, 3, 4, 5, 6 and so on, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7 and so on. You just name these numbers what we call, you just remember the concept that called number system. There we have discussed 0, 1, 2, 3, 4, 5, 6 and so on, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 and so on. What we call, is this a real numbers or integers or rational numbers? What it is? All these are the real numbers. All these are the real numbers. These are not integers. These are all the real numbers. Range is also a real numbers. Range is also a real numbers. How range is also a real number? Suppose if we take decimals, 0, 1 we have, in between 0 and 1 you can take any one decimal. Suppose if we take 0.5, then f of x is what? That also we will get 0.5. You just plot a graph, you just draw a point in between this graph, we will get 1 point. If you want, you can verify it at your home. Suppose if we take in between 2 and 3, let us take 2.5. Let us take 2.5. F of 2.5, that outputting value is what? 2.5 we will get, right? 2.5, 2.9, 2.8, 3.9, 4.9, that all numbers we will found in this f of x equals to x. Hence, therefore, all these are the real numbers. Domain, codomain, range. Domain, codomain, range are all the real numbers. It is the identity function is very important for 5 marks. You just practice at your home 3 or 4 times, you will be perfect. The question will be like this: define identity function. Define identity function, draw the graph for this function, and also find out domain, codomain, range for this function. The question will be asked like this: define identity function, draw the graph for this function, also find out domain, codomain, range for this function. Hence it is identity function, very important for 5 marks. You just note down in your notebook with the help of a graph sheet. Now let us move on to the next type function. That function called constant function. Constant function. What is the definition for this function? The function f from R to R, the function f from R to R is defined by f of x equals to you just see the title for this function, constant function we are defining, right? Constant function we are defining. Then a function f from R to R is defined by f of x equals to, that output value is also a constant. That output also is also a constant. F of x equals to c. C is nothing but a constant. Or you can write it as a k. F of x equals to c for all x belongs to R. This symbol represents that for all x belongs to R. Here we are putting the values of x, that values should be a real number. X is nothing but here we are putting the values of x, that values should be a real numbers. For all x belongs to R is called a constant function. Hence it is the definition for the constant function. Now let us draw the graph for this function. Before that, let y equals to f of x equals to c. If you want to take y, you can take f of x equals to c. We have to draw a graph for this function. You can take any constant in place of c. You can take any constant, either 4, 5, 6, 7, 8, 1, 2, minus 1, minus 2, minus 3, minus 4. You can take any number. I am going to take the number 4. Let us take a constant function f of x equals to 4 I am taking. Let us take the table for this function. It is x and it is f of x equals to c. F of x equals to c. C we are taking 4. Right? Let us draw graph. Let us draw table for this function. To draw a graph, let us take the values from minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 and 5. Now you just substitute the values. You just take the values in place of, you just put the values x here. Then what we will get? If f of minus 5 equals to what? You just put the values x here. Finally what we will get? F of x equals to 4. If you put any kind of value in place of x, finally we will get the value 4. Then f of minus 5 is 4. F of minus 4 is also 4. F of minus 3 is also 4. F of minus 2 is also 4. F of minus 1 is also 4. Because we are defined that f of x equals to 4. You can take any value in place of x. Finally we will get the value 4. Suppose if we have the value f of x equals to 5. Then f of minus 5 is also 5. If we have the value 5. F of minus 2 is also 5. F of minus 3 is also 5. Here we have the value 4, so that the outputting value will be 4 only. Also this 4 is a range for this function. That function is a f of x equals to 4. F of 0 is also 4. F of 1 is also 4. F of 2 is also 4. F of 3 is also 4. F of 4 is also 4. F of 5 is also 4. Hence it is a table for the function f of x equals to 4. Let us draw the graph for this function. it is x-axis, it is y, it is negative x-axis, it is negative y-axis, and it is negative x-axis. Let us take the values on x-axis, positive x-axis, 1, 2, 3, 4, 5, 6. Let us take the values on negative y-axis, -1, -2, -3, -4, -5, -6, and so on. Let us take the values on y-axis, positive y-axis, 1, 2, 3, 4, 5. Let us take the values on negative y-axis, -1, -2, -3, -4, -5, -6, and so on. Let us take the values in the graph. You just observe the table for this function. Here we have the table. You kindly note down in your notebook. Let us take the values on this graph. Finally, we will get a graph for the function, for a constant function f of x equals to 4. You just observe the table. Suppose if x equals to 0, f of x is 4. You just see the table. If x equals to 1 plus 1, then y is also 4. F of x is also 4. If x equals to 2, then f of x equals to 4. If x equals to 3, f of x is also 4. If x equals to 4, f of x is 4. If x equals to 5, f of x is 4. If x equals to 6, f of x is 4. If x equals to 7, if x equals to 8, if x equals to 9, if x equals to 10, and so on. For all that values, we should take the value 4 only, because it is a constant function. If x equals to -1, f of x equals to +4. If x equals to -2, f of x equals to +4. If x equals to -3, +4. If x equals to -4, +4. If x equals to -5, f of x equals to +4. If x equals to -6, f of x equals to +4. Right? You just see the table for this function. I am just writing the values and the graph. You just join the points. Finally, we will get a constant function. That function will be a f of x equals to 4. You just join these points. You just join these points. Finally, we will get f of x equals to 4. Hence, it is a graph for the function f of x equals to 4, or it can also be written as y equals to 4. Y equals to 4. Now, what about domain, codomain, and range for this function? What about domain and codomain, range for this a constant function? Domain, codomain, and range. Domain, codomain, and range. Domain is what? Codomain is what? What about range? I already told you in our previous function that function is an identity function. What about the domain, codomain, and range? In the definition itself, we have the domain and a codomain. You just observe the definition. The function f from R to R, it is a real number, it is also a real number. It is a domain and it is a codomain, right? Domain will be a real numbers, codomain is also a real numbers. Domain is a real numbers, codomain is also a real numbers. What about range? I already told you that the outputting value is called a range. The outputting value is what? 4, 4, 4, 4, 4, 4, right? Therefore, range for this constant function is 4 only. range for this a constant function is 4 only. Hence, it is a constant function. You just note down this function along with the graph in your notebook. Okay, dear students. Hence, it is the class for today. In the next class, we will continue with the other types of functions. Thank you.